So in this video, I'm going to finish up the rest of the further math paper 2 in 2020. By the way, as usual, I'm not doing module 2 because that is the only module I'm not very comfortable with. So let's have a look at module 1, matrices. The three major shopping centers in the large city, East Mall, Grand Mall, and West Mall. Sounds like East Mall, Chatty, probably Chaston. Grand Mall, no idea where that is, but West Mall, let's say it's in Doncaster, Westfield. In the actual VCE math exams, we have to use pseudonyms. Otherwise, probably some legal issues. Are owned by the same company. The total number of shoppers at each of the centers at 1 p.m. on a typical day is shown in matrix V. Write down the order of the matrix V. Order of the matrix, so we have one row and 3 columns. Probably the answer I would write down is 1 by 3 matrix. Each of these centers has 3 major shopping areas: food, clothing, and merchandise. The proportion of shoppers in each of these 3 areas at 1 p.m. on a typical day is the same at all 3 centers and is given in matrix P below. Grand Mall's management would like to see 700 shoppers in its merchandise area at 1 p.m. If this were to happen, how many shoppers in total would be at Grand Mall at this time? So we know there are 700 shoppers in merchandise area. Let's say, let X be the total number of shoppers. And we can use the ratio to figure out each part. For example, in the food area, there will be 48%, which is 0.48 times X. That's in the food area. In the clothing area, I would say it's 0.27X, and that is C. Finally, this one is the one we want to figure out. 0.25 times X will be in merchandise area. They tell you there are 700 shoppers in this area, so we equate 0.25x and 700. Therefore, the total number of people will be 2,800 shoppers. The matrix Q equal to P times V is shown below. 2 of the elements of this matrix are missing. So we want to complete the matrix Q above by filling in the missing 2 elements. And we want to interpret the element Q 2, 3. In this case, I'm going to shift to my CAS calculator and see what will be a possible approach. First of all, I would like to define the matrix V. Normally, I would say it's V1, okay? V1 is defined as a row matrix. So we select the matrix button and type in 1 row, 3 columns, choose OK. Then we fill in 2300 and press tab again, 2700 and then 2200. So we have defined our matrix V1, and we can see from the var button, it's a defined matrix here. Similar approach, we can define P1, okay, to represent the actual matrix P. In this case, this is a column matrix. We have 3 rows and 1 column. And the first entry is 0.48. Press tab to shift to the next entry. This will be 0.27. And then this will be 0.25. Press enter. OK, it's also defined. Don't worry about the fractions because, as I said, I'm teaching method and primarily, and my cast setting is on the exact mode. So if you press Control Enter, you will see, okay, the output will be converted into decimal form, okay? So let's get rid of the previous line and keep going. In this question, we want to compute Q, which is P times V. So we type in var P1 multiplied by var V1 and hit Control Enter. You will see these numbers are representing each element in this 3 by 3 matrix. So what you're going to write is 1296 and 729 for the two missing elements. And what does the element Q23 represent? So 2 means, okay, the second row, which is here. And the 3 is the third column. So we want to see, okay, 594, okay? 594 people. And let's have a look. So this is 1296, 729. And let's locate Q23, 2, 3. So it's this entry here. W means Westmore Shopping Center. And C means closing area. What information does the question provide for us at 1 p.m. on a typical day, okay? So let's say at 1 o'clock p.m. on this typical day, there will be, or if you choose to use the present tense, you can say there are, okay? There will be 594. Let's just stick with the present tense. There are 594 shoppers in the closing area of the Westmore Shopping Center. Finished. The average daily amount spent in dollars by each shopper in each of the 3 areas at Grand Mall in 2019 is shown in the matrix A 2019 below. On one particular day, 135 shoppers spent the average daily amount on food. 143 shoppers spent the average daily amount on clothing. So that corresponds to F. And that number of shoppers will correspond to C. And finally, 131 shoppers spend an average daily amount on merchandise. So this will be big M. And in this question, read the question very carefully. We want to write a matrix calculation using matrix A 2019, showing that the total amount spent by all these shoppers, total amount spent by all these shoppers. Okay, so we want to use the matrix calculation to show something. That means the answer itself doesn't matter as long as we have the correct calculation. So how can we calculate this total amount? I would say, okay, finally, this is just a 1 by 1 matrix, which is just a number. If the final output is 1 by 1, because this matrix has order 3 by 1, we want to use another matrix to pre-multiply this A 2019. So this number and this number, they must match each other. This is 3. And finally, look at this number here. This would be 1. 1 by 3 times 3 by 1, okay? That means I could use, okay, a row matrix times a column matrix. So this will be, okay, 135 in the food area, 143 in the clothing area, and the merchandise area, we have 131 shoppers. For each area, the average spending amount, $21.30, $34 exactly, $14.70. So if you multiply these two matrices, you will get this number multiplied with that. 135 multiplied by 21.30 plus this number with that number, 143 times 34.00 plus 131 times 14.70, okay? Don't forget, this is a matrix calculation. What you must include is the squared bracket here to represent the matrix, just in case, okay? Be very careful with that small detail. So this will be 9663.20. And we can verify if it's true on our CAS calculator. Right, so let's have a look. $135, 143, 131 multiplied with another 3 by 1 matrix, 21.30, 10, 34, and 14.70. Control Enter. Exactly the same thing. They don't show you the 0 behind the 2 because 0.20 is the same thing as 0.2, okay? Finally, let's move on to the last part. In 2020, the average daily amount spent by each shopper was expected to change by the percentage shown in the table below. Right, so food, the price for food will be 1.05 times the original price. Decreased by 15%, which means 0.85 multiplied with the existing price. And a decrease by 1%, this will be 0.99, 99% of the original, okay? The average daily amount in dollars expected to be spent in each area in 2020 can be determined by forming a matrix product of that. So we want to write down the matrix K. A common mistake for students to make is like 1.05, 0.85, and 0.99. No, this is not correct because this is a 1 by 3 matrix, and the pricing matrix is a 3 by 1 matrix. Using that will form you a 1 by 1 matrix, which means it only provides us the total spend, okay? So how can we find the expected amount to be spent in each individual area? Probably that is not the way. So we want to consider, okay, our output will look like that. Something here, something here, something here, which means our final matrix will still be a 3 by 1 matrix. That means, okay, I will guess there is a 3 here multiplied by something. Look at the first number here. This will be 3. This 3 matches with that 3. So what we really want to write down is a 3 by 3 matrix. So let's say, okay, 21.30. This is $34.00. And 14.70. And if we put a 0 here, and put a 105 here, okay? You can see this number will be multiplied with that, plus 0 times that, plus 0 times that, which will only give you 21.30 multiplied by 105%, resulting in the increased price afterwards, okay? Using the same logic, we can say 0, 0.85, 0, and then 0, 0, 0.99, okay? So this is actually the K we want to write down, but make sure you address the question, okay? So finally, we write out this bit. We are just having a K here rather than K times the A 2019, okay? That's it. Question 2, pretty easy. The preferred number of cafes and sandwich bars in Grand Mall food court can be determined by solving the following equations written in matrix form. The value of the determinant of the 2x2 matrix is 1. Using this information to explain why this matrix has an inverse. That means the square matrix is invertible, or it's non-singular, okay? If the determinant of any matrix is 0, that means matrix A is singular or inconsistent. Or not invertible. Refer to this bit, okay? That something 5 minus 9, 4 minus 7 is 1, which is not equal to 0. This is our reason. Therefore, the square matrix is non-singular and invertible. So does the matrix, the inverse, exist. Right. Write the 3 missing values of the inverse matrix that can be used to solve these equations. We can use our calculator. Raise this matrix to a power of -1, okay? I will use another page to illustrate that question. So our original square matrix is 5, -9, 4, -7 to the power of -1. Press enter. The inverse of the matrix. And then if we want to find x and y, we need to pre-multiply this matrix with the right-hand side, which means this will be multiplied with 7, 6, which gives you 5 and 2. X will be 5 and y will be 2. Alternatively, if you don't want to use the matrix method, call upon your knowledge from year 9 or year 10 to solve these simultaneous equations. Manual 7371, okay? Press OK. And you can say, okay, get rid of the curly bracket if you wish. Just type in 5x minus 9y gives you 7. And 4x minus 7y will be 6. Exactly the same thing, okay? So -7, -4, 5. And the preferred number of sandwich bars for Grand Mall's food court. X is 5, Y is 2. But make sure we answer the question. We just want the preferred number of sandwich bars. So preferred sandwich bars, 2 sandwich bars. Okay, move on. An offer to buy the West Mall Shopping Center was made by a competitor. One market research project suggested that if the West Mall Shopping Center were sold, each of the 3 centers, West Mall, Grand Mall, and East Mall, would continue to have regular shoppers, but would attract and lose shoppers on a weekly basis. Let Sm be the state matrix that shows the expected number of shoppers at each of the 3 centers n weeks after West Mall is sold. A matrix recurrence relation that generates values of Sn is given by Sn plus 1 equal to transition matrix multiplied with Sn. The transition matrix is this guy here. This is my initial state. Calculate the state matrix S1 to show the expected number of shoppers, S1. And we need to fill in the 3 entries. And then we need to deal with the rest 3 marks. So a general strategy for question 3, define the T and S. Let's go to the calculator first. So I will press Control up, press menu, insert another problem. Here, add another calculator, define, space, T1 equal to 3 by 3 matrix, 0.80, 0.09, 0.10, 0.12, 0.79, 0.10, 0.08, 0.12, and 0.80. And then define S0 equal to 3 by 1 matrix, 2, 5, 0, 0, 0, 0, 2, 3, 4 zeros, and 2, 5 zeros. Press enter. Then S1 will be given by T1 multiplied by S0. Control enter. This will be the first S1, the first state matrix after the first transition, okay? Let's just fill in the numbers first. Two, 4, 0700, 2, 3, 1700, 207600. Using values from the recurrence relation on page 23, the graph below shows the expected number of shoppers at West Mall, Grand Mall, and East Mall for each of the 10 weeks after West Mall is sold. What is the difference in the expected weekly number of shoppers at West Mall from the time West Mall is sold to 10 weeks after West Mall is sold? Give your answer correct to the nearest thousand. So we want to find the difference between this number here and this number here, because we are looking at the graph of the West Mall shoppers, okay? What I'm doing here is use our calculator again. So after 10 transitions, I will calculate T1 to the power of 10 multiplied by S0. Control, enter. Westmore. Which one is Westmore? Westmore is the very first entry, okay? Very first entry. Initially, we have 250,000 minus this number here. Control enter. We will get 30239.35, but we want to round that to the nearest thousand. So get rid of these numbers, okay? So the answer should be 30000. 30,000 shoppers. That is the difference. Then the next part of the question wants us to find the weak number to achieve the maximum number of shoppers in Grand Mall, okay? Grand Mall. So it's between the 4th and the 10th week. So let's have a look. The 4th week will be T1 to the power of 4 times S0. Okay, Grand Mall, which entry is that? The middle entry. Then we calculate T1 to the power of 5 times S0. Control enter. You can see, compare these two numbers, you will see the number is slightly higher than the previous one. 3525, 3660, okay? Keep going, T1 to the power of 6 times S0. Control enter. Yes, this number is again slightly higher than the previous one. Go to T1 to the power of 7 times S0. Control enter. 233709. Keep going, see how we go. T1 to the power of 8 times S0. See, 233688. This number here is slightly lower than this one here, roughly 20 something people less. Therefore, this is where you reach the maximum number at Grand Mall. And we want to quote the specific N number, okay? Therefore, N is 7. So 7 weeks or the 7th week after West Mall is sold. Let's just complete these two questions. Only one mark question. Doesn't need to include any working out, but anyway, let's say S10 is equal to T to the power of 10 times S0. This gives you 219760.647, blah, blah, blah. And 233627.438, blah, blah, blah. 226611.914, blah, blah, blah. So the difference is equal to 2540. Take away 219760.647, blah, blah, blah. This will be 30239.3526. Correct to the nearest thousand. 30000 thousand, okay? Shoppers. Trial and error. S7 is T to the power of 7 times S0. Just look at the middle value. 233709.9 something. S8 is T to the power of 8 times S0. This will give you something like 233,688.8 something. Therefore, maximum number is approximately 233,710 when it reaches n equals 7 or 7th week after W is sold. Okay? The week number. In the long term, what is the expected weekly number of shoppers at Westmall? Round the answer to the nearest whole number. So we all know the idea of equilibrium state or long-term behavior. S infinity is approximately equal to t to the power of a very large number times S naught. So let's have a look at our calculator and see how we can compute the steady state. For example, we can see T1 to the power of 100 multiplied by S naught. Control Enter. If you really want to see whether these numbers are steady, put an extra power, 101. Control Enter, and compare these two outputs. No drastic change. So you will see, okay, this weekly number of shoppers at Westmall, which one it is? Okay, the first entry, 218884. Nearest whole number? Yes. That will be your answer, okay? All right. Finally, question 4 for the matrix module. This time, the recurrence relation has a little bit difference. It has a plus b for each transaction. So you must include that in your calculation where appropriate. This is your transition matrix. And okay, now we use the letter R. And the given one is not R naught, it's R2, the second steady state. In the third week, I suppose R3 is T times R2 plus B, okay? Probably I want to define T, B, and let's define T and B first, okay? Because I already used the T1, then I can use T2. Point 78, point 13, point 10, point 12, point 82, point 10, point 10, point 05, point 80 defined. And what is my B? Define B2, be consistent with the 2 here, okay? 3 by 1 minus 400, 700, and 500. Okay, so my R3 will be T2 multiplied by R2, 3 by 1, 2, 3, 9, 0, 60. Why don't we just, anyway, just type in whatever on our exam paper, 250,840 and 192,900. Don't forget to plus B2. So this will be our answer, and I want to see the number of shoppers at Westmore. I suppose it's the first element, okay? Right, to not get you confused, what I'm doing on my calculator is just typing in the matrices and the calculations to calculate R3. R3 is equal to 237,966, 254,366, and 1912,68. Therefore, expected shoppers at W 237,966 shoppers. Determine the expected number of shoppers at Westmore in the first week after it is sold. Actually, in this case, we are trying to work backwards. So if I want to find R1, how do R1 relate to R2? It's actually T times R1 plus B, giving you the matrix R2. But now we want to isolate R1. So how can we achieve that target? Firstly, we want to get rid of the plus B. For example, do the same thing on both sides, okay? So we minus a B here, minus a B here. Then we transcribe what we should get from the previous calculation. R2 minus B is T times R1, okay? Now, because our R1 is on the right-hand side, we can swap sides. T times R1 is equal to R2 minus B. All right. Now, what we isolate is the matrix R1. Our next target is to eliminate the T in the front. So how can we cancel a matrix in the front? We are not dividing any matrix. In fact, we're getting their inverse and pre-multiply the matrix T with its inverse, so we can get an identity matrix. For example, if I multiplied T with T inverse, this will be an identity matrix. It's like a number 1 to be multiplied in the front of any other number. Alternatively, we have T inverse multiplied by T, which is also the identity matrix. In this case, which one should we choose? Definitely, we need to choose this one because we know the order of matrix multiplications are not commute, not convertible, okay? So in this case, don't forget, do the same thing on both sides. Leaving some space for us, so I pre-multiplied with T inverse. And this bit is T inverse multiplied with R2 minus B in a bracket, okay? Bracket is important here. So now we derived our R1, which is T inverse times R2 minus B. And we can calculate whatever we need on our calculator. Now we should have T2 to the power of minus 1 because the letter T2 we defined is the T in the question, multiplied with R2. Where is R2? This matrix here. Minus B. But remember, you should have a bracket here around these two matrices. Then we press Control, Enter. This will do. Quite nicely written numbers. Okay, integers, no decimals. Don't forget to specify whatever needed by the question. Westmore, expected number of shoppers at Westmore is 24130. And this is your final answer, okay? Alrighty, end of module 1, section B. I will do my solutions to modules 3 and 4 in the next 2 videos. See you then.